Hello, everyone. My name is Kexin, and I'm a PhD student from the University of Wisconsin-Madison. In this talk, I will share our research on exploring the design space of optical see-through augmented reality head-mounted displays to support first responders in the field. So let's start with what are first responders? First responders refer to people with specialized training who are the first to arrive and respond to fire, medical, or other emergencies. First responders include different types of disciplines, such as firefighters, law enforcement officers, emergency medical services, and communication center and 911 services. They engage in a wide range of tasks ranging from low-risk routine activities like responding to 911 calls to very high-stake scenarios such as rescuing people from burning buildings and dealing with active shooters. And among the variety of duties they practice, tasks in the field are particularly challenging and dangerous because first responders need to directly confront the emergencies and perform on-site duties at the incident locations. And tasks in the field often involved a lot of unpredictable and rapidly evolving hazards, demanding extra physical and mental efforts from the first responders to make life or death decisions within seconds. However, the technology to support first responders in such challenging environments are actually very limited. And in the recent years, augmented reality's head-mounted displays have been recognized as a promising technology to support first responders for a few reasons. First, they can intelligently recognize the real-world environment and rendering in situ augmentations. Specifically, through the optical see-through head-mounted display, they can present a head-up overlay directly onto the real world without blocking natural vision. Secondly, compared to handheld technologies such as the mobile AR, the head-mounted form factors avoid attention switching between the physical environment and the screen, which allow first responders to fully focus on their task. In addition to that, the AR HMDs are equipped with multiple input sensors to recognize users' behaviors, allowing for multi-modal interactions through hand gestures, voice commands, and even gaze. So, exploring how AR technologies can support first responders have gained some attentions. However, most of the prior works focus on the mobile AR, and very limited research have investigated the unique opportunities and challenges posed by the head-mounted AR. There is an even smaller body of work that places first responders within the AR environments to understand their firsthand experiences. So, to fill this research gap, our research aims to thoroughly understand first responders' needs and concerns with using head-mounted AR devices in the field. We adopt a user-centered approach by giving first responders first-hand experiences with state-of-the-art AR HMDs to comprehensively explore the design space from three perspectives. First, we study hardware, wondering what are the benefits and drawbacks of the AR-HMD form factors for FRs in the field. Secondly, we investigate the interaction techniques afforded by AR-HMDs, studying what are the benefits and drawbacks of different interaction techniques for a variety of FRs. Lastly, we contextualize FR with different AR cues to understand what forms of AR augmentations are preferred in different emergency response scenarios. To do this, we conducted semi-structured interview with 26 participants that covered 3 in-the-field first responders roles. Specifically, 7 of them are firefighters, 6 of them are law enforcement officers, 6 are EMS and specifically paramedics, and 7 of them are both firefighters and EMS. We let all participants to wear HoloLens 2, which is a state-of-the-art AR HMDs, so that they have the first-hand experiences with the AR device. We then start our study with the hardware assessment, in which we ask participants about their wearing experiences, such as whether the HMD felt heavy to wear or any restrictions to their body movements. After that, we let participants experience 3 types of interaction techniques on HoloLens 2 by using the TIPS application, which include multiple in-the-air gestures, as you can see from figure A to C, and also the speech commands and gaze-based interactions, such as the gaze cursor showed in figure D. After fully understanding the capabilities and interactions of HoloLens 2, we conducted a brainstorming sessions with 4 types of ARQs as the design probes. These ARQs are identified from our systematic literature review on existing AR research for first responders. And based on that, we designed and implemented these 4 types of ARQs to contextualize first responders in the AR environment. These cues are, first, overview cues, which visualize the overview of a site via a head-attached 2D map and a 3D floor plan. Then, the highlighting cues that emphasize an object of interest by adding a colored shaded overlay or a contour around the object. And the third type of the cues are directional cues, which include an arrow indicating a target, such as a fire extinguisher shown in the figure E, and an array of arrows connecting into a path. And lastly, the labeling cues, which labels the object or human of interest using symbolic icons and the text. For each cue, we ask participants to brainstorm whether this type of cues would be helpful and what task or information could be augmented by such design in order just to better understand their needs and preferences across multiple types of first responders roles. With that, we now discuss our findings. So through the first-hand experiences with HoloLens 2, the majority of our participants reported feeling very comfortable wearing it, but at the same time, participants identified 3 issues with the current hardware design of AR HMDs. First, the field of view is limited, which is largely due to the lower edge of the HMD block their peripheral vision and caused bifocal view that impaired their judgments to the surroundings. And the second issue is about the stability of the device. All EMS and law enforcement participants found the ARHMDs are stable and tight enough for their task, but the firefighters were concerned that the HMD may fall off when worked in extreme situations involving large-scale body movement, such as crawling in the confined space. And the third issue is about the integration to existing equipment. Few participants point out that the head-mounted AR form factors is actually not compatible with the firefighter's helmet and the face shields. And interestingly, our findings indicated that the head-mounted form factors may potentially trigger some social acceptance and trust issues because wearing the AR glasses changed the traditional appearances of first responders. For example, P1 explained his concern with wearing the AR HMD when interacting with patients. Quote, "If you think about the medical situations that we go to, it's their worst moment in their life. So if they are looking at you and going like, what the heck are they doing here? I can't trust them. This defeats the purpose of first responders." Moreover, through the interaction techniques explorations, we found that the speech command was favored by all 3 types of first responders, which allowed hands-free interactions with minimal distractions. Other interaction techniques such as gaze and vibration might be useful for compensating some specific challenging scenarios, such as using gaze interactions in noisy environments when speech commands cannot be accurately recognized. And for the ARQs, we found that first responders' needs and preferences for each type of ARQs are both role-specific and scenario-specific. Taking the directional cues as an example, firefighters want them to be visually salient so that they are easily recognized for backtracing in the low visibility, smoke-filled environment. However, paramedics desired more subtle directional cues to support emergency vehicle driving, avoid blocking real-world environments. And another example would be the overview cues of the maps. Although all participants found the AR map is a very helpful tool for spatial awareness, different types of first responders want different information on the map based on their needs at a specific moment. And when deciding what information should be presented on the map, we need to be very careful to avoid information overloading. So, in order to provide needed information while avoiding information overload, participants proposed a multi-layer map design. Specifically, this design idea mentioned that there should be a base map that consists the most fundamental and structural elements of a space that are needed all the time, such as the walls, the windows, and exits. And in addition to the base layer, the different first responders need some on-demand information. As P10 envisioned, quote, if there would be an ability to put layers on the map, so if there were no hazard materials, it would be nice to be able to say, okay, I'm just going to pull up the hazard materials layer. If there's nothing there, then I'm just going to wipe that out. For more details about the design space of each ARQs, please check our full paper. So, by thoroughly exploring the design space of AR-HMDs through the three perspectives we just talked about, we drive a set of comprehensive design guidelines to inform practical and safe use of AR-HMDs in the field. Our design guidelines cover the three aspects of AR-HMDs correspondingly, and we made each guideline to be actionable with concrete examples and evidence from participants' preferences. In this talk, we will demonstrate one example for each aspect. And start with the hardware design. It must follow the established safety standards in the emergency response. Because of the high-risk nature of the in-the-field task, AR-HMD should fully conceal first responders' eye area for multiple hazards prevention, such as smoke or blood splatter. And the current hardware design of semi-closed glasses should be improved by fully wrapping around the eyes of first responders. For the interaction techniques, the speech command should consider noisy environment. Specifically, an improvement could incorporate noise cancellation technology with voice identification algorithm to distinguish the first responder's voice from the background noise. And the speech commands should also be carefully designed to avoid conflicts with their verbal communication with other team members. And lastly, the ARQs should be adaptive or adaptable to the emergency level of an incident. For example, the overview cues we mentioned earlier should provide first responders the most essential information from a glance, allowing them to make the decision within seconds. At the same time, it should also contain more details and allow more flexible interactions in the low-risk situations. Overall, our contributions are threefold. First, we adopted a user-centered approach to deeply explore the design space of AR-HMDs in supporting different first responders' roles in the field. We also provided first responders the first-hand experiences and contextualized them in AR environments for deeper understanding. Last but not least, we drive a comprehensive and actionable design guidelines from multiple perspectives of AR-HMDs. Please check our full paper for more information, and thank you for listening.